Hi, my name is Halima Olapade. I'm a senior software engineering major at Drexel University, and today I'm presenting my senior capstone project called Diggly for the NCWIT award application. So what is Diggly? Diggly is an application that is built to enhance the Wikipedia encyclopedia. What it does is it smartly extracts relevant information from Wikipedia articles and then transforms that information that is extracted into graph visualizations of the articles. The purpose of this is to make Wikipedia easy for any user to understand. When you go to a Wikipedia article, there's usually a lot of text, and sometimes that can be overwhelming. So the purpose of our application is to take that information that's in these articles and cut it down to only what is fundamental to understanding the concept. And also, what is more important here is that it helps you to understand how one article might be linked to another article. So why are we creating Diggly? We're creating Diggly to make an application that makes it easy for you to learn about complex topics without spending a ton of time doing that. So we're trying to immerse our users in something we describe as a casual learning experience. And by using a casual learning experience, we're kind of creating a playground for the curious mind. The motivation for this project is to simplify the Wikipedia user interface. For example, you see on the left-hand side, this is what the solar system article on Wikipedia currently looks like. It's a big blob of text that tells you a lot of information about the solar system. However, you would have to spend a lot of time reading through that. In comparison, what we're trying to do is to build a graph that conveys a lot of information very, very quickly. So on the right-hand side, you see what this might look like. The solar system is in the center, and you have outgoing links to other topics. So for example, here we have solar system, and then an outgoing link to the sun. The sun is part of the solar system. It's a big, important part of this topic that we're looking at. As a user, when you look at that, it can tell you a lot of information very quickly. In our application, users can hover over these nodes to get quick summaries of what those topics are about. So then you can very easily learn about the solar system and the sun without having to read through all of that text. So here is our approach. First of all, we simplify the user interface by converting it into a graph. Next, we minimize text information by only giving you text when you hover or on the side of the application. And then we allow the user to continuously explore topics. So you start at a topic and you click and click and click until you are satisfied. And finally, what we're doing here is we're allowing the users to build for themselves a unique learning experience, something that's driven by the person who's controlling the mouse. So here's a screenshot of what our application looks like. You notice in the top that the user can search for a topic, any topic of interest. However, we're adding more functionality. First of all, the user can look at recently discovered topics. So these are topics that they've looked at in the past, in this case, absolute zero or Palestine. Another thing that we're adding is we're adding a layer of randomness. So first of all, the user can look at trending topics, so Wikipedia articles that are linked to topics that are currently popular. For example, now it would be the Super Bowl. Or most popular topics that other users of our application have found interesting and have explored. And finally, we're doing a random search. In this case, the application would find any random topic in our database and allow the user to search that. Adding this layer of randomness, we're keeping with that idea of creating a casual learning experience for somebody who might just be curious about learning something new today. Next, the user explores the selected topic. So in this case, the main topic being explored is absolute hot. You see that it's the main node in the graph, and then on the right hand side over here we have a simple description of that topic. Below here we have a history, and what the history does is it allows the users to see which nodes they clicked on to get to the current topic. Finally, in the application, when the user hovers over these nodes, the related nodes, you can see a quick summary of how those nodes are related to the main topic being described. Another functionality that we're adding to our application is the ability to bookmark a topic. In this case, the user has bookmarked absolute zero, so that later on they can click on this topic and go back to exploring and continue from where they stopped before. Finally, the Diggly application leverages user click behavior. This means that when a user initially comes into our application, they might see two linked topics. By clicking on linked topic A versus linked topic B, the user is telling Diggly that the first linked topic is more relevant. So at a later time, when other users come into our application, Diggly is more likely to show topic A because other people have already found it to be more interesting. Python implementation overview. The backend is implemented in Python, MongoDB, and Django, whereas the front end is done with the D3 graph visualization library for JavaScript. Finally, the data is requested from the Wikipedia public API, and when it's requested, it's parsed, and then application relevant information is extracted and sent to the visualization library. Digly is still in the development phase and will be completed in May 2016. However, we've already created the publicly available APIs to expose the data that's used on the front end for graph visualization. Here's an example. Currently, you can request information about any Wikipedia topic via its page ID from our servers. I just made the request and returns a summary of a topic that I just requested. You can also do a /explore to get more information about how other topics are linked to that main topic. The next step of our development is to do article content parsing and to develop the algorithm for figuring out relatedness of topics. Thank you for listening.